Thank you. Thank you everyone for coming. Um, Today I'm going to talk about me and my team's journey to observability in our services and how that enabled us to track every function execution in production. So a little bit about myself. I'm the Ingress lead for the IBM Cloud Kubernetes service, which includes Red Hat OpenShift on IBM Cloud as well as our hybrid IBM Cloud satellite offering. And really this started out for me and my team as not a journey to observability, but as a journey to resiliency and improvement for our service. We started out with the goal of saying, how can we make our services better? How can we make them more available, more reliable, and better for our users? So today I'm going to talk about, why we felt we needed to make a change, how we evaluated the solutions, how we landed on observability, and then what the actual real user and business impact was for those changes. So a little bit of background about our services. So my team provides managed DNS, managed application load balancers, and managed TLS certificates and secrets integration with IBM Cloud Kubernetes service, IBM Cloud Secrets Manager, which is a Vault. So before we went through this observability journey, we went through a bit of a microservice journey. Originally, we had one giant conglomerate. It was hundreds of thousands of lines of code, and it was pretty difficult to manage. So we split that out into 3 separate components, each with a single responsibility, and it made the ownership and dependency model a lot easier. All of our microservices have the same general architecture. So they have an API layer, and then they have an async worker layer. And that async worker layer may be triggered by an event bus, by a database callback, or some kind of ticker interval or time of day interval for some async work. We also have external dependencies that all of our services interact with. So this might be a DNS registrar, it might be a Vault service, it might be a Kubernetes cluster, and the communication can be initiated either within our microservice to the dependency or from the dependency to our microservice. So when we started on this, we started probably where most people do when they feel like they need to make improvements in their service. We started with testing. So we do tons of regression testing in pre-prod environments. We do something like 60,000 regression cases a week for all of our services. We worked through decoupling components and refactoring some of our services to make them better unit testable and higher code coverage. And that's a great place to be, to feel like you're confident in your regression testing and you have a very good testing profile. But it doesn't tell you what your services are doing in production, and it doesn't tell you how your services are impacting your users. So I love this quote from Charity Majors. She's one of the co-founders of Honeycomb, which is one of the premier observability offerings in the space. And she says, not testing in prod is like not practicing with a full orchestra because your solo sounded fine at home. And so what I take this to mean, it's not test only in prod, right? It's, there is a delta between your prod environment and your pre-prod environment. And it's about understanding what that delta is. Maybe the infrastructure is different. Maybe the operating model is different. Maybe the way your services are orchestrated is different. And it's about understanding those differences and then asking yourself, can you adequately measure those for your service? Can you understand them? Do you know where to look? Do you know what you're looking at when you're comparing a baseline set of functionality, whether it's in regression testing or whether it's across different shards or different regions in production? So for us, right, the question is, were we able to understand what our code was doing in prod, either, whether it be across different shards or versus pre-prod? And we found ourselves in a particular cycle that might be familiar for some people in this room. You have an issue in production, and then you go and you look at your monitoring system and you look at your metrics and your logs. Maybe you're ahead of the curve and you have distributed tracing implemented and you look at your trace data. And you say, shoot, I don't have enough data to tell me what happened for this particular production incident, right? I can't get to the root cause. If you listen to the talk here before lunch about the 5 whys, maybe you get to that 3rd or 4th why and you don't have an answer for it. So you think, okay, I'll go and add instrumentation to my service. I'll push that out to prod. Maybe you're 3 times through this cycle and you're getting desperate and you're adding I am here logs in your service for debugging, and then you wait around for it to happen again. And this was kind of the spot we were at for our services before we started this journey. And to be frank, it wasn't what we really wanted from ourselves. It's not a great operating model for enterprise production services to not know what's going on. And so we said, okay, this is a problem, and we need to fix this problem. So what are our requirements, right? If you're familiar with the Google SRE handbook, it talks about the 4 golden signals. So that's latency, throughput, errors, and saturation. And so really what we wanted is we wanted to track the 4 gold signals for every operation in our services. And we wanted the metadata to be consistent across all of the pillars of observability. So this was kind of before the events were added as sort of that 5th pillar. But across our metrics, our traces, and our logs, right, we wanted to have the same correlating information. So we wanted to be able to pair our metrics with our logs. We wanted to be able to see the same metadata in the logs when we're looking through them and building views as we can in the trace data. And then one of the key critical components is we wanted automatic instrumentation. And that's key because that gets you out of the cycle of saying, I don't have enough data in this particular spot. I have to make a change to a production service to then be able to visualize what's happening. And then we needed consistency in performance, right? We can't introduce latency into the hot path that's going to affect our users because we wanted observability. So those are really how we started evaluating our solutions. And I talked a little bit about our microservice architecture. In distributed systems, there's a few different orchestration models. Sometimes you have API-based, sometimes you have an event bus, maybe you're using Kafka or something like that. Some have a data-centric model. But oftentimes, your system is a combination of a bunch of those, right? And it's not one single model, so it's not one single instrumentation point. So for us, it was really important that we were able to not only observe interactions between our services and the edges of our service, whether it be the requests on the network to dependencies or to the database or to our other services, right? We needed to be able to observe a single service and what encompasses it, right? Maybe there's not an external factor that triggers processing in our service. We still need to be able to observe that event. And observe what's happening. So there are a lot of existing solutions out there, and of course we took into account and went and did a technical analysis on those solutions. So some of them, like OpenTelemetry sidecars, or service meshes, that could be Istio, Rancher, Red Hat Service Mesh, right? Those are really good for observing interactions between services, like I mentioned, but it still leaves a gap. And then you have full-fledged, observability suites. You have Grafana Cloud, you have Honeycomb, things in that area. Again, those don't provide you instrumentation in your services. You still have to do that manually, and then they aggregate the results and kind of help you visualize and understand the data. If you want to observe the service internals, it kind of requires a context-aware implementation for your service. And we found that the existing libraries, they didn't handle the use case we wanted, and they added a development burden without adding that value that we really needed. So that led us down the path of creating something custom. And what we came up with is, what I lovingly call now the observability context. So if you're familiar with Golang, most of our microservices are written in Golang. It is an abstraction on the standard library context. And what it does is it allows us to pass a context throughout an execution flow from parent to child, and it maintains that metadata across the observability pillars, and it maintains that observability context within that, within that code context as you move through the execution flow. So it provides consistency, it provides all of the pillars of observability, and it allows us to really get, a consistent implementation across all those pillars. It also allows us to simplify our implementation for things like logging. Right? We can then implement more efficient buffer logging, so we can reduce things like fsyncs and syscalls, expensive allocations and copies of logger metadata, and we can really optimize the buffers. So this meant that not only were we getting more consistent metadata, but our logs were showing up in the ingestion service in the order we were expecting them to, and it was actually having a positive performance impact on our services through these optimizations. The context automatically records execution time for every instrumented function. So you get histograms for P90 of every single function, or whatever p-value you want to measure. And then it uses exemplars based on trace ID to carry out that mapping between metrics and traces. I'm sure many people here are familiar with Prometheus limitations on cardinality. And so, you don't want to put all of that metadata that you might have in a span or in a log in your metric, but you do want to correlate the two systems so that way you can easily move between them. And then it automatically creates a trace for each execution flow. So we, before we started this, there wasn't a thing as consistent profiling. Now there are tools out there that allow you to do consistent profiling, but this is as close as we could get to that. As far as kind of creating a trace with a lot of metadata for every single execution flow in production. So how do we implement it? The context is built on a plugin model. So this allows us to expand it in the future as needed, right? The traces and the metrics and logs all are implemented in a similar fashion and invoked in a similar way. So this means in the future we can add things, if we want to do consistent profiling, or another pillar of observability gets added and we want to integrate that into our system. We don't have to make a change to the instrumentation in our code. We can simply add a new plugin to the context, and it will be invoked at the same time as all the other plugins. So again, what it looks like in practice, you initialize the context. Potentially you provide metadata at initialization. Sometimes you provide it later if it's not available right away. And then for every function that you want to invoke the context, it's 3 lines of code. You initiate the context with the method start, and then you defer the method end. And then for any error that you want to track for that execution, whether you want to do SLOs or SLIs, then you just point to that error on the method end. The other thing about instrumenting the standard library context is that you can generally pass this down to dependency libraries without needing to modify their implementation at all, which was really important to us. So we can still maintain kind of that request context from a traditional standpoint, whether it's based on an API or if you're making requests out to external services. So the implementation for us was, not that burdensome. It was pretty lightweight. And what this means is now for 90% of every single function that we execute in production is instrumented with this context, which means we get the data that I was talking about, right? We get very in-depth histogram data. We get very in-depth metrics, traces, and logs for every function. And that really satisfied the requirement of saying, hey, we need every function within a service instrumented and not just at the edges. And also, right, it's not automated. It doesn't get added automatically to the code, but it's really easy to catch if a function doesn't have that when it comes in on a PR. Okay, great. So now, we spent all that time. I've been hammering this to the team. They're probably pretty sick of it. Cool, we have all the data. Now the question is, what do we do with all that data that we are pushing out to our systems? And this is where observability becomes really powerful, in that it really changed the mindset of our team about how we're approaching our development. So I think most people are probably familiar with the SDLC. It's sometimes conceptualized as a cycle or a figure 8. And generally it goes, you have planning at the start, you have analysis and architecture next, and then you have development, and then you have testing, and then you have promotion, and then you start the cycle over. And this is how we were operating as a team, right? We were using Agile, we were using sprints, and we were falling into this SDLC. And it just wasn't as effective as we really wanted it to be. And part of the problem is that software development isn't linear like that, right? You're not only in one phase of the SDLC for a particular software at a time. And then software development also isn't only about features. There are loads of other things that go into software development that then get left off of that. So I like the new model from Emily Freeman, who works for AWS. She calls it the revolutionary model. And basically the rings on this model are roles, right? So you have architecting, you have developing, automating, deploying, operating. And then the spokes are things that apply to all of those roles, right? You have securability, flexibility, scalability, testability, and observability. And you kind of move in and out of those rings as you see fit. So sometimes you're doing architecture, sometimes you're developing, sometimes you're building automation, sometimes you're deploying, right? It's not a static, I got a feature request in from a customer, I'm heads down on that feature until I've made it through the SDLC, and then it goes to production, and then I'm done. I'm in and out of the rings as needed, and I need to apply those same things across all of the roles, right? If I go to my security and compliance team and I say, hey, I have a new operating model for my service in production, but it's not secure, they're going to tell me you can't use that. And similarly, right, you should take that approach with testing and observability, right? If you can't observe your deployment process, if you can't observe your automation, then you should approach that the same way as if you can't observe your code. So we now kind of take the approach that you would with test-driven development, which is, as you're designing your code, you're saying, how can I test this? How can I test the interaction model? And you're thinking about testing as part of the design and implementation. And the same with observability now, right? When we get a feature request in, when we're working on some other project, we're saying, hey, how can I observe this in production? Not shallowly, how can I know it's working? How can I see the impact that it's providing to our users? How can I know that it's running in a performant way? And we need to think about that, all the time for our code, and not just when there's an incident. So, I started out by saying we asked ourselves, can we see what's happening in production for our services? And we couldn't. So now let's go back to the same question, right? Can I understand the performance of my services in production? So these are some screenshots of some graphs that we have for production. We're kind of somewhat standardizing on the Grafana stack, and most of our, metrics data and trace data can be visualized in Grafana. So I'll take a very basic example here, right? We'll go with an API example. And maybe I pull up this dashboard in the morning and I'm looking at it and I say, okay, I see 17,500 responses, right? And I want to drill down to see what happened in those, right? So I can drill down and I can break it out across a whole bunch of different categories, right? I can see it by service member, by node, by path, by latency, however I want to choose. And then I can drill down a step further into the call stack. And this is where it gets really powerful is you can start overlaying that onto other metrics, right? So I can say, okay, this API now had a spike in latency for this period. I can figure out which function execution within that call stack had increased latency, and then I can overlay that on things like database read-write time, disk I/O, CPU usage for the host, and maybe it's something as simple as like, hey, that's weird, every top of the hour, when database backups go off, then we see a little bit of latency in this API because database writes are now a little bit slower. So that's a kind of a very real use case that we've actually seen, but we can do this for any API, for any function, async or non-async. So the really cool thing about this is now I'm covered from an observability standpoint forever, right? I'd never have to go back to the team and say, hey, how come when I went to look at, this particular, API or this particular use case in prod and I couldn't see it. I don't have to worry about that anymore. For every function, for every new feature, for everything that gets added, our telemetry, our metrics, our logs, our traces are automatically there. So what that does allow me to focus on is, looking at user impact of my services. So now it's about going out to that product management dashboard and saying, okay, let's look at the funnel data, right? And I can compare that with the engineering data I have to say, at this particular time in our busiest region, we're seeing a latency in provisioning. And what that's showing us on the product management dashboard is that in the funnel, people want to use our service less after this, right? They don't want to buy it as much, or they don't come back as often. Okay, now I can go and figure out, why is it latent in that particular time of day? And one thing, as a use case example that we found, is job contention and missed callbacks. Were causing sort of like a sync cycle miss on our provisioning. So once we cleared that up, then we saw that provisioning went back to normal during that time period, and then usage also went up after that. So it's not about, my code is better, that's great, right? But what does it do for your users, and what does it do for your business that your code is better? And another thing that we really are able to focus on now is aggregating across all user statuses and experiences, right? Before it was focused on, 500s or bad experiences that were driven by our service. But now we can focus on things like 400 requests for our service, where we say, hey, that's weird, 10% of requests to this API distributed across a large amount of users, and they're getting 400 responses. Let's go fix the UX of this API so it's easier to understand for our users. So these are a couple, shallow metrics. I think when I originally went to our product management team and I said, hey, I'm not gonna do any new features for the next 3 months because I really wanna tackle stability and observability in our services, I think they probably thought, well, we don't have to really pay attention to this guy because he'll be fired pretty soon. But, we took that time and now it bore out in that we can see the tangible real world results. So some shallow metrics from our service, right? Customer tickets by year. This is basically advanced customer support. And from 2021 to 2022, it essentially grew linearly with usage of our service. So what that basically means is you can't devote development effort to new features because you're supporting existing features. So anytime the PM team comes to me and says, hey, one of our large customers wants this new feature, I say, I'm sorry, unless you give me a new person, I can't do it because I'm already supporting the other features that are in prod. In 2023, compared to 2022, we had a 75% reduction in total tickets open. So that's a huge value add for our development team to be able to focus on features and work that drives real value. And then similarly, critical impact events over time. So these are basically a breach of SLO that is running up on an SLA violation. So the potential to lose the business money. In 2021, we were averaging roughly 1 to 2 a month, which is definitely not the spot you want to be in when you lead a large team. 2022 and 2023, we had a single impact event each year, and the cool thing about 2023 is it was a dependency situation, and we were actually able to very quickly identify what was going wrong with all of our observability data and push out a mitigation, and the MTTR of that incident was significantly lower than it would have been in past years. And then this is the core of really what people want to know when you say, hey, I went on a microservice journey, I went on a reliability journey, I added observability. They're like, cool, he keeps up with the fads, but what does it mean? What it means is that our roadmap got much more populated. So in 2021, we essentially were doing one large feature release every half a year. So you had a very long build-up, you had a lot of stress, you released a feature, people went on vacation because they were worried about it, and then you started the cycle over. As we started going through this journey, right, in 2022, now we're releasing a major feature once a quarter. So we've doubled our feature output. And when I say major features, I mean these are features that we have, potentially $1 million deals on the table for, that, we're driving business value. And then in 2023, right, so this snapshot is taken probably beginning of October. So we've 1.5 times our feature output for from 2022 to 2023. So our goal as a team has been one, major feature per month. I think that we're closing in on that. We still have some work. But it's not being driven by us being business focused. It's been driven by us saying we want to, organically improve our product. We want to focus on making the developer experience better, because we don't have as many incidents. We don't have as many customer tickets of people saying, hey, this API was slow for me today, and we can't see what happened. So we spend, hours of time explaining to them, why we can't see that. And what it is now is we show up to work and we get to tackle the fun problems of, when someone comes to me now and says, hey, I think your API has a problem in production. It's like P99 is 10 milliseconds slow, and we're request hedging to the database because the margins are so slim on that. And that's fun. It's a lot more fun. I'm a lot happier now than I was, 2 years ago, to be able to say, when we show up to work, we're being creative, we're tackling tough problems because we're not spinning our wheels on things that, are bogging us down and that we don't have answers for. So like I said, it's a journey. We still have a long way to go. There's always improvements, but I'm excited for what we've been able to accomplish so far. Any questions? So we still use the OpenTelemetry libraries for sending data. For example, for tracing, we use OpenTelemetry libraries. I don't think we use it for metrics under the covers. If I remember correctly, in Go, it's using the Prometheus register library still. We're not using the sidecars is what we're not using.
Basically, Prometheus and OpenTelemetry in a mix.
Yep.
I guess the strategic direction is OpenTelemetry?
Yes, we're definitely looking to incorporate that, any way we can. I would say it's the path forward.
So if there is no more question, then let's say thank you to Lucas for his valuable expert insight, and applause.